Hello, good afternoon. Today we are presenting our project Spotify Analytics, and our team members are myself, Akshara Sarode, Shubhashri, and Pravin. So, moving on to the next slide, understanding the song popularity. We analyze two datasets, popular and non popular Spotify tracks, to find trends and features like energy, tempo, and danceability. Moving on to the next slide as we present the tools and technologies. So, we use the modern web stack combining the front end, back end, and the database tools. On the front end, HTML, CSS, and JavaScript, along with Bootstrap 5 with Jinja to inject dynamic content. The backend was built using Flask, a lightweight Python web frame, and our database was hosted locally using MySQL, selected for its reliability and performance. Data cleaning and pre-processing was done by using pandas, ensuring CSV data was normalized and ready for insertion. So moving on to the next slide. Our workflow began with two Kaggle datasets, each containing 2000 Spotify tracks. Using pandas, we clean the data by removing any duplicates, and we split the data into multiple entries like tracks, albums, and artists. And the clean data was inserted into a normalized MySQL database, and the Flask server handled the CRUD operations and analytical queries by connecting to this database. So, moving on to the database design. So, the schema follows a fully normalized relational model, and the artists, albums, and everything all are linked to the foreign keys. Many to many relationships are managed via track artists and playlist tracks using the junction tables. And this structure allows a modular, scalable, and efficient querying while preventing the data redundancy. The overall platform supports CRUD operations, analytical modules, and clean user interface. So, yeah, moving on to the demo.
So here on app launch, we are here at the landing page and we have different sections for the various tables that we have. And the first one, let's see, it's artist table. And we have all the data that is there from the tables and we can go add an artist, edit or delete. So first, let's try to add an artist. Here we see that it is successfully added. Now we can try to edit an artist and it is updated. And also let's try to delete an artist. Delete it. Similarly, we have different sections for each table where we can perform the CRUD operations. And finally, here we have the visualizations tab where we have these various graphs which is built using SAS.js. The first one is a bar chart which shows top albums by number of tracks. And next we have a pie chart which shows the playlist count per genre. And finally, we have this line chart which shows the number of tracks released per year. All this data is dynamic and it gets changed as and when we remove or add records to our table.
So one of the main challenges we faced in this project is data duplication and cleaning. So initially the raw CSV format had a lot of duplicates and there were several issues with the formatting. So we cleansed everything and standardized the data format and applied normalization techniques onto this CSV file and broken it down into 6 different tables. So by this normalization, we were able to fix data redundancies. Moving on to the next slide. And finally, what we learned from this project is we were capable of building an advanced SQL queries such as common table expressions and JSON and how to handle JSON objects from this one. And we were also able to do full ETL jobs without using external tools and completely relying on data on our database itself. So this is one of the major learnings we have obtained. Finally, the reference. So these are some of the reference which we mainly project. So that pretty much sums up about our project.